So in this video, we're going to talk about classifying numbers. Why? Because we have to, and it's on the EOC, keeping it real. Okay, so let's just get this over with. So here we go. Classifying numbers. This is just vocabulary, vocabulario, call it what you want, okay? But what I do want you to know is that all of these vocabulary words fall under the same umbrella. So everybody go ahead and draw your squiggly. Okay, and we're going to call it real numbers. Okay, everything falls under the guise or the umbrella, if you will, of real numbers. So if you think of money, dinero, the green, yes. If you think of money, we're going to start with the number 1. Okay, so if we start with number 1, 2, 3, ... onto foreverness in the positive direction. Okay, we're going to call these natural numbers. Okay, remember, when you're thinking of natural numbers, think of money, think of starting with a $1 bill and going on to into foreverness in that positive direction. Now if I just add a 0 to the list, okay, here we go, I added a 0 to my 1, 2, 3. Now we're going to call this next vocabulary word, okay, number 3. So we have real numbers, which is everything. Natural whole numbers start with the number 0, okay? So we just added the number 0 to the list, and now 0 and beyond into the positive direction is called whole numbers, okay? Now we're going to go into, where is my green? I don't have green, so now I'm just going to have to choose what I have here. If I'm going to add the negative side of the number line, ... Okay, if we start with a -1 and go on to infinity in the negative direction, okay, now we have added to the list, okay, and now we're going to call all of these integers, okay, integers. Okay, and so if I were to ask you, for example, the kind of question you're going to get is -2 a natural number? Well, you would say no, okay, because -2 it's an integer, but natural numbers start with the number 1 and goes on into the positive direction. So no, -2 would not be a natural number. Okay, so now next we're going to talk about rational and irrational numbers. Okay, so let's just draw a squiggly here and a squiggly here. All right, so rational numbers deal with fractions, square roots, decimals, that kind of thing. So when we're talking about rational numbers, we're talking about like the square root, like perfect squares, like the square root of 4 is 2. Or, we have a decimal. Say, supposing you get an answer on your calculator that's like 0.333 and keeps going, okay, it repeats. It's a decimal that repeats, and so that's considered rational, okay? Or if you take if you have a decimal that terminates, okay, this is your answer. In your calculator you got 0.45, okay, and that was the answer, and it stopped right there. A decimal that terminates, that stops, that's rational. So rational numbers, or if you have like a fraction like 2/3, okay? So rational numbers, okay, are, your perfect squares, your repeating decimals, your decimals that terminate, that actually stop, or like a fraction. But now, let me grab the pink again. I thought I had a green, but we're going with it, okay? So now we're going to have irrational. Irrational numbers. So you probably guessed it. We're going to talk about decimals with and radicals with irrational numbers. Irrational numbers, okay, so we have like the square root of 3, the square root of 3, or like the square root of 10. Both of those are not perfect squares. That would fall into the irrational category. We also have a decimal that does not repeat, okay? So here it was a repeating decimal. In the irrational, it's a decimal that does not repeat, and what's the most famous decimal that does not repeat? Pi. So I actually got it for you, so I'm going to write this down. So pi, we all know, is equal to 3.14, but you know, we don't usually know beyond the 3.14, but we have 159.265, and it keeps going and going and going. So that's an example of a decimal that does not repeat, okay? And then, or a decimal that doesn't terminate, it just keeps going. So you, like, if you have 0.101001000100001, you get the idea. A decimal that doesn't terminate, it just keeps going and going, that's considered irrational. So when you get a question on the Algebra EOC or on my unit exam, it's going to ask you questions like, you know, is the number 0 a natural number? You would say no, because natural numbers start with a positive 1 and go into the positive direction. They'll ask you, is a radical 3 a number that's not a perfect square? Is radical 3 a rational number? Well, you would say no, because only perfect squares, okay, only perfect squares fall into the rational category. So it's questions like that. This is vocabulary, questions like that that we need to know how to answer. Okay, that's classifying numbers.